Hey guys, sorry I am out again. You are going to continue your work on rational functions. So we have a rational function meaning anything that can be written as a fraction. So notice we have two fractions here and a whole number, which we can write as a fraction. And in order to deal with these, we're going to need a common denominator. So what we need is over here, we need to have a denominator of, instead of 1, x plus 5. So to do that, I'm going to multiply the top by x plus 5 and the bottom by x plus 5, because x plus 5 divided by x plus 5 is just 1. Anything multiplied by 1 is just itself, so that works with all the rules of math. So when I distribute, I get negative 2x minus 10 on the top and x plus 5 on the bottom. Then I have plus 1 over x plus 5 equals x over x plus 5. Well, now that we have a common denominator of x plus 5, I can go ahead and multiply this entire equation by x plus 5, and that'll cancel out with all of the denominators. Now notice, had we just done that to begin with, we would just have to multiply this with the negative 2, and these would cancel out, and we'd end up with exactly the same thing. So you can actually go ahead and start by just multiplying by that common denominator to go ahead and fraction bust this. So now we have negative 2x minus 10 plus 1 equals x, and this becomes a very simple algebra problem. So pull our x's together, we get negative 9 equals 3x divided by 3 x equals negative 3. And then you do have to check these because they are rational. If we were to plug the denominator back in and get something like 0, so for example, had we had x over x plus 3, and then we plugged in this negative 3 business, that would make this undefined. Now in this case, the denominator, if I have negative 3, that's not going to do anything, so that is our answer, and that answer looks good to go. But it is possible to get no solution on these if the value you get would actually make the function undefined. All right, let's try this next one. Adding a layer of complication here. Before I can deal with getting a common denominator, fraction busting, any of that, I need to factor this business, because right now it looks kind of similar to this, but not enough that I know what to multiply by to keep things simple. So 1 over x minus 5, I'm just repeating. I'm going to put 2 over 1 because I know I'm going to be dealing with fractions here, equals 5 over. I'm going to take out the greatest common factor here, which is x. So we'll take our x out, and we're left with x minus 5. Okay, so now I can see that I'm going to need to multiply by x and x minus 5 if I want to cancel out all the denominators. That'll cancel out this x minus 5 and leave me with just x times 1, so x. On this one, when I multiply by x and x minus 5, I'm just left with both of those, so we now have 2 times x minus 5, because again, they're trying to cancel with the 1, nothing's canceling out, equals everything cancels out over here when I multiply by x and x minus 5, so we're left with just 5. So now on the left, we can start multiplying and combining our like terms here. So this becomes, we're going to have to take this 2x and distribute it to both x and negative 5. So now we have x plus 2x squared minus 10x equals 5. Now I have an x squared and x's, so I'm going to need to bring everything to the left-hand side and try and x factor this. 2x squared, combining like terms, minus 9x, subtracting 5 from the other side, minus 5 equals 0. So now I'm asking myself what multiplies to negative 10 and adds to negative 9. That would be positive 1 and negative 10. And that gives us x plus 1 over 2 times x minus 10 over 2. 2 is going to come out in front here. This gives us 2x plus 1 and this becomes x minus 5. I think in this section they're actually asking for what x equals, so we would get x equals 5 and x equals -1/2. Now again, like I said, we've got to plug this back in. If we plug 5 back in here, that's going to break this function right here and make it undefined. It's also going to break this one, giving us completely undefined. So this is not going to work because it's undefined if we plug it into the original. So that means that my only solution is going to be x equals -1/2. Okay, same idea as last time, except now it's not just a greatest common factor. We need to actually try and x factor this denominator. What multiplies to 28 and adds to -11. So let's see, 4 and 7, both negative. -4 times -7 is positive 28 and adds to -11. So now we have 1 plus 1 over x minus 7 equals x over x minus 4 times x minus 7. Okay, so we can see that we need an x minus 4 and an x minus 7. So we're going to multiply by x minus 4 and x minus 7 across the whole thing. That's going to leave us with x minus 4 times x minus 7 from my first term plus x minus 4 from my second term, because that denominator is going to cancel out. And that's all going to equal just x, because both these denominators cancel out. This business is going to require an area model, but again, we kind of know what it is because it's back to this original, right? It's x minus 4 times x minus 7. So we know this is going to be x squared minus 11x plus 28, or you could do your area model there, plus x minus 4 minus x equals 0. Again, I subtracted this x to the other side. Okay, so now we want to combine like terms. X squared is by itself. We have -11x plus x minus x. These x's are just canceling each other out, so it's minus 11x again. And then 28 minus 4 is 24. So now we're asking ourselves what multiplies to 24 and adds to -11. Let's see, 3 and 8. -3 and -8 multiplies to positive 24, adds to -11. So we get x minus 3 and x minus 8, which means that x equals 3 and x equals 8. Going back up here, neither 3 nor 8 is going to break this denominator and make it undefined. Therefore, both these answers are correct, and you would put them in with a comma into Delta Math. Okay, last but not least, this one is a little bit tricky just because of this business right here. First thing you want to do is rewrite that. So we're going to start with x over x plus 2 plus 5 over negative x plus 2 equals 2x over x minus 2. If I take a -1 out of this, actually that was a bad way to show you. If I take a -1 out of this, -1, that makes this one positive and this one becomes negative. So then I have x minus 2 again. So what I'm going to do is make this negative go up to this 5. So now I have x minus 5 over x minus 2. This is over x plus 2 equals 2x over x minus 2. Now this is very similar to the ones we've done in the past. We're going to multiply by x plus 2 and x minus 2. The plus 2 is going to cancel out here, leaving me with x times x minus 2 for that first term. And then we're going to have -5 times x plus 2, again because the x minus 2 is going to cancel out, equals 2x times x plus 2, because the x minus 2 will cancel out. Now we need to distribute, move everything to one side, and see if we can factor this. This first bit gives us x squared minus 2x. Then we're going to distribute this -5, -5x minus 10 equals, we're going to distribute this 2x squared plus 4x. And we're going to subtract 2x squared and subtract 4x to the other side. It's 2x squared and minus 4x. All right, so we get negative x squared, negative 5 and negative 2 is negative 7, plus a negative 4 is negative 11. X minus 10 equals 0. We can factor a negative 1 out of all of this. X squared plus 11x plus 10. Asking ourselves what multiplies to 10 and adds to 11. That's going to be 1 and 10. So we end up with negative 1 times x plus 1 times x minus 10. So x equals negative 1 or positive 10. We look back up and neither of those would break the denominator, so both of those are valid answers. Hopefully that all makes sense and gets you through the rest of this Delta Math assignment. That's your job for today. Have a good rest of your day.